Let's practice analyzing and visualizing the correlation between two numeric variables using R. First, we use the set.seed function to ensure that the random numbers generated are consistent, so our results are reproducible. Then, we create 100 math scores and 100 science scores using the renorm function, with different means and standard deviations for each. Originally, these two variables are unrelated. However, in this example, we artificially introduce a correlation by adding half of each math score to the corresponding science score. Although such data processing is rare in real analyses, we've manipulated the data in this way to highlight the concept of correlation analysis. By using the cor function, we can easily calculate the correlation coefficient between the two scores. In this case, we find a value of about 0.81, which indicates a very strong positive correlation. It's important not just to check the correlation coefficient, we also need to look at the p-value using the cor.test function. If the p-value is less than 0.05, it means that the correlation between the two variables is statistically significant. In addition to the Pearson correlation coefficient, there is also the Spearman method, which is useful for ranked or nonlinear data. Comparing the results from both methods is a good practice. If you have multiple variables, you can create a correlation matrix by passing the entire data frame to the cor function. To visualize the correlation matrix more intuitively, you should install and load the ggplot2 and kurplot packages. Using the visualization features of the kurplot package, you can see the correlations at a glance through the size and color intensity of circles. The stronger the correlation, the darker the color and the larger the circle. In this session, we practiced generating data in R, calculating correlation coefficients, testing their significance, and visualizing the results. The R code is posted in the community post.